Hi. In this week, what we are going to do is look at digital processing. How do we process a signal in the digital domain? Uh, and what we are looking at is basically processing of analog signals in the digital domain. So, to start off with, let me take a very simple example. This is a fairly straightforward example, and it is simple to the extent that you may find it trivial, but I think it would be helpful to just start off at this point and build from there. Okay, let's say you have an analog signal V1, and what you want to do is you basically want a V out which is equal to V in minus, sorry, not V in, because I started off with V1, so the signal has to be V1 minus, let's say, V2. So it's basically a difference of two voltages. Let's make it a little bit easier also by saying that V2 is a constant here. Okay, so it's not it's not a uh, it's not a variable signal, but just a constant. So let me write it as A. Okay, so A is just a number, probably one or two or something. And what I can do is I know how to build an analog circuit that does this processing, right? So you take a Vn and the output is basically V1 minus A. And I'm sure you can build an analog circuit. And if you can't, I'm sure you can go back in your notes in Medical Instrumentation 1 and figure out how you can do that. Okay. Now, what we want to do is we want to do the same function using a digital system. So, how are we going to do that? So, you have this V1, and this V1 is an analog signal. Okay. So, the first thing that you'll have to do is you'll have to take this V1 and convert it into a digital signal. And this is done using an ADC. And once you've done that, what you can do is you can take uh, this signal into a digital processor. Let's just write, let's say, a microcontroller. So this digital processor that we're talking about is a microcontroller. And what the microcontroller does is it does this operation that we want to do. So it does V1 minus A. And then the microcontroller sends the signal to my digital to analog converter, let's say DAC, which converts it back into an analog value. And this analog value is V out equal to V1 minus A. Okay, fairly straightforward. Now, my question is what kind of processing would what would the microcontroller do to get this V1 minus A? So, first of all, what does V1 look in the digital domain? And then what does it mean to do V1 minus A? Okay. Now, I'm sure this is also fairly probably clear to you already, but let me just repeat it. So V1 is an analog value, and what we get after the ADC is a digital value, right? And we already discussed that what do we mean by a digital value? We have sampling, so we are not taking all the points in the signal. So if our analog signal looked something like, let's say, like this, then what we mean by sampling is that we only take certain time instance of the signal, right? And at these time instance, the values at these time instance, we are going to digitize them by first quantizing them and then assigning them with a code. Okay, so what we get at the output is basically an array of numbers, isn't it? So we get, let's say, some array of numbers a0, a1, a2, a3, and on it continues, right? So we get this array of numbers, and that is the digital value that we get. And what does it mean to get v1 minus a then? What it basically means is that with each of these values, so with a naught, you replace a naught with a naught minus a, and then you replace a1 with a1 minus a, and then you replace a2 with a2 minus a, and so on, right? This is what you want to do. You take each of the digital values that you have got and you subtract it by A. And once you've done that, your signal is basically V1 minus A. And then you can convert it into analog value and uh, get the signal that we actually wanted here. Now, of course, here I'm assuming that you have enough sampling frequency, you have a high enough sampling frequency that you don't get aliasing, and that your ADCs and DACs are working properly and you have adjusted their ranges and other factors and all well. But if you have done that, this is the way you would do a differencing in the digital domain.